How to solve a second-degree quadratic equation. This is the general equation, the general quadratic equation of second degree with coefficients a, b, and c. A for x squared, b for x, and c as the parameter, equal to 0. You want to find the x, real x, such that ax squared plus bx plus c equals 0. It means that when you find the roots or zeros with this quadratic formula, those numbers are such that when you replace them over here, x equal 1 in this case, this has to give 0. This is the case, and the same for x equal 2. This is the case for this polynomial x squared minus 3x plus 2, where a is 1, b is minus 3, c is 2, and here is the quadratic formula. It is very well known. Just replace the numbers over here in the formula and check all the calculations over here, all the operations done here, and see how you get to this answer. 3, because it's minus b, and b is minus 3 gives plus, and so on. Check those steps. 9 minus 8 is 1. The square root of 1 is 1. Then you have usually two solutions. One, when you subtract 3 minus 1, which gives 2, divided by 2, and you get the 1. And when you add here, which is 4 divided by 2, which is 2. And you have the two roots of the quadratic equation. See that when you replace x by 1, this gives 0. The result is 0. And when you replace x by the number 2, it also gives 0. Then this is the way to know if you found the roots. And those are the real roots or zeros. Roots or zeros of the quadratic equation. Then we know now that when we have this quadratic equation or this polynomial of second degree, complete polynomial, the roots or the numbers that when replacing the x give 0 are 2, 1 and 2, which are known the roots or zeros of the polynomial. How to use the zeros of x squared minus 3x plus 2 to factorize it. This way, use this method. X squared minus 3x plus 2 is equal to x minus 1, this root, times x minus 2. Check. S times x is x squared. This gives x times minus 2 is minus 2x, and this minus x minus 3x, and this number times this number is 2. Check that it works. But see how easy can you factor or find two factors of this quadratic polynomial, just writing these roots, but with a different sign. you have to say minus 1 because you want that when you replace the x by 1, this should give 0 because this is the root. You cannot say x plus 1 because when you replace the 1, it gives 2. If you say x plus 1, it has to be x minus the root, so that when you replace the root here, it gives 0. The same for 2. And this is the way to factorize this quadratic polynomial. Too easy. Using the roots. Much better than that. How to solve inequations. Sorry. Inequality is not inequation, it's inequality. Okay, let's solve the inequality x squared minus 3x plus 2 greater than 0. Instead of finding the roots of x, instead of finding the roots of x squared minus 3x plus 2 equals 0. This is an equality or equation, and this is an inequality. We will use the function fx equal x squared minus 3x plus 2 is a parabola. It opens up because this coefficient is positive. It opens up like this one, opens up. And the zeros are x equal 1, see here? And x equal 2. Then you have the idea of how this parabola is. We have here a graph. And then, if you want to find the x such that x squared minus 3x plus 2 is greater than 0, those x have to be here, because this is fx greater than 0. All those are the x that solve this inequality, and those also. Then, this is an interval that goes from minus infinite to 1, and this other goes from 1 to infinite. Then the solution to this inequality, is the union of those intervals. It means that if one x is here, solves the inequality or complies with the inequality, and if the x is here greater than 1, also such x that are outside of this set, of this union, like those doesn't comply with the inequality, but with the other inequality, this one. For those x, the inequality, the same quadratic, is less than 0. Okay? Then the solution to x squared minus 2x plus 2 less than 0 is just the interval here, which is 1 up to 2. All the numbers, all the s between 1 and 2. Then, in this way, using the parabola, you can solve the quadratic inequality.